Okay, so in this question, they tell us that someone leaves a cup of hot chocolate on the counter in the kitchen, and they want to know which of these graphs represents the cooling of, they don't say it, but the temperature of the hot chocolate over time. And, if you have hot chocolate and you leave it out on the counter, right, what's going to happen to it? Well, over time, it gets cooler. And here, they're talking about the cooling of the hot chocolate, right? Over time, what's going to happen? Now, you don't even need to get into any kind of thermodynamics really, or a sophisticated understanding of the wonderful way that we measure temperature, cooling, and heating. Just look at some of the graphs for a moment. Here in the third one, what's happening? Well, time is on the x-axis and temperature is on the y. So your hot chocolate starts out hot, and then over time it decreases, and after about 3 minutes, right, it's at the lowest temperature, and then it starts to rise again. I don't know about you, but if I leave something hot out on the counter, once it's began to cool, unless I'm putting it back in the microwave or something, or back on the stove, or heating up the liquid some way, it's not going to start getting hotter again randomly, right? It just continues to cool, right? And here, the same thing is true in the fourth choice. This one as well. It's like over time, your liquid decreases in temperature and then increases. And that's not what's going to happen, right? It's going to continually decrease over time. So I want to cross those two out. Now here, do you choose one or two, right? Well, this is what I mean. You don't have to really get into it too much because look what happens here. After 5 minutes, the temperature of the hot chocolate is at 0. And if you've ever had a cup of hot chocolate and waited 5 minutes, you know that after 5 minutes it's probably still warm, and in fact will not just be suddenly at 0 degrees Fahrenheit. It won't be that cold. That's quite cold if you think about it, right? At 30 degrees Fahrenheit, it begins to snow. So at 0 degrees Fahrenheit, you'd have a very, very cold cup of hot chocolate. And that's just not going to happen, especially after 5 minutes. So here, the only reasonable choice is 1, and if you notice, the way the liquid cools is not linear, right? And in fact, it kind of makes sense that it cools pretty quickly, and then seems to slow the rate at which it's cooling as it goes along, and kind of steadies out over here at around drinking temperature. In this case, I guess around between 60 and 80 degrees. So here, the most reasonable choice is the first one. Thanks.